Welcome to this .NET MAUI ComboBox tutorial. In this video, I will demonstrate how to integrate AI-based searching and customize the filtering process to achieve accurate results, even when there are no exact matches, in the Syncfusion .NET MAUI ComboBox. First, I open an existing MAUI application. I've already configured the .NET MAUI ComboBox control and specified a source path for displaying food items. I have also set up the .NET MAUI text input layout to display hint text that appears as a label above the input field when the user starts typing. To learn how to add the .NET MAUI ComboBox control to your MAUI application, watch the video linked in the YouTube card above and the description below. Now I run the application. Once the application is loaded, I'll enter a character in the input field. You can see the items that start with the entered input displayed in the drop-down box. Next, I will show you how to display accurate results in the combo box, even when there is no exact match. I will begin by integrating an AI service into the application. First, I open the NuGet Package Manager and switch to the Browse tab. I search for the Microsoft Semantic Kernel NuGet package, select it, and then install it in my project. In this example, we will focus on using Azure OpenAI. However, you may choose any chat completion service. If you decide to use Azure OpenAI, make sure that you have access and have configured deployment through the Azure portal. After the package is installed, I create a class called ComboBox Azure AI Service to handle interactions with Azure OpenAI. I begin by declaring three constants. Endpoint, which specifies the Azure endpoint URL for API calls. Deployment name, which refers to the name of the AI model. And key, which is the API key for authentication. These values are essential for connecting to Azure OpenAI. Next, I declare private variables to manage the OpenAI kernel, chat history, and completion services. I've defined chat completion to handle chat responses. Kernel is the core handler for AI requests, and chat history to maintain a log of the conversation history. To initialize the Azure OpenAI kernel and set up the components required for interacting with Azure's OpenAI services, I create a method named getAzureOpenAI kernel and call it in the constructor. Within this method, I create an instance of chat history to store the conversation's history. I include a try block to ensure that any exceptions that occur during kernel initialization are safely handled without crashing the application. Inside the try block, I use the create builder method to start building the kernel and add the Azure OpenAI chat completion service to securely connect to the Azure OpenAI service using the provided credentials. After that, I finalize the kernel configuration and assign it to the kernel field. Then, I retrieve the chat completion service from the kernel to generate AI chat responses. The catch block handles any exceptions that might occur during the kernel setup process. To generate an AI response for a given user prompt by interacting with the Azure OpenAI service, I create a method called getCompletion. First, I check that both the chat history and chat completion are not null. Second, I add the user's input to the conversation history. I send the current conversation history and kernel to Azure OpenAI to retrieve the AI-generated response. I add the generated AI's response to the conversation history, convert it to a string, and return it to the user. Finally, if the chat history or the completion service is not initialized, I return an empty string. Next, I create a class called ComboBox Custom Filter that implements the iComboBox filter behavior interface to support AI in providing intelligent filtering, including handling typos and phonetic similarities. To manage communication with Azure OpenAI for generating filtered results, I create an instance of the Azure AI Service class, which was defined earlier. I define a property to hold the list of items in the combo box, and another property to store the filtered items after processing user input. Within the constructor, I initialize the Azure AI service and the items collection. I now create a method named filterItems using Azure AI. In this method, first, I ensure that the filtering logic is executed only if the user input is not null or empty. Next, I formulate detailed instructions for Azure OpenAI, specifying rules for filtering such as phonetic matching, case insensitivity, and typo tolerance. I also instruct it to return only valid matches. Additionally, I include the user input, the list of items, and an output template as a sample format for the AI's response. I send the constructed prompt to Azure OpenAI for processing and retrieve the filtered results as a string. To extract the filtered items, I split the AI's response into individual items using a new line as the delimiter. I trim any white space, filter out any empty lines, and convert the response into a list of filtered item names. Finally, I check whether the filtered items collection already contains data, and if it does, I clear the existing data to prepare for the new filtered results. To add all the matching items at once to the filtered items collection, I create a class and define a method called addRange. Next, I define a for-each loop that iterates through each item and adds those items to the collection. In the filter items using Azure AI method, I use the addRange method to update the filtered items collection with matching items. Here, I match the filtered items with the original items collection and use the startsWith method to ensure that each filtered item corresponds to the beginning characters of an original item name. Finally, I return the updated filtered items collection, which contains the results of the filtering operation. To filter items in the combo box based on user input, I move to the getMatchingIndexes method. Here, I retrieve the list of items from the combo box and assign it to the items collection. I concatenate the names of all items in the items collection into a single string, with each name separated by commas. This string is then passed to Azure OpenAI as part of the prompt for filtering. I create a sample output structure for the Azure OpenAI prompt by concatenating the names of the first 5 items, separated by new line characters. I call the filter items using Azure AI method to send the user input, the list of items, and the reference output template to Azure OpenAI. Finally, the filtered items are returned as the output. To configure the custom filtering behavior for the combo box, I navigate to the main page XAML. Within the combo box control, I define the filter behavior property and add the combo box custom filter class using the local namespace. Once done, I run the application. As I type characters in the combo box, you can see that the drop-down menu displays suggestions even if there is no exact match. Let me wrap up this video. You have learned how to integrate AI-based searching and customize the filtering process to achieve accurate results, even when there are no exact matches in the Syncfusion .NET MAUI ComboBox. If you would like to see the working code for this example, download it from the GitHub link in the description below. I have also included a link where you can check if you qualify for our community license, which provides you with a free license key for all our .NET MAUI controls. If you found this video helpful, click the like button and subscribe to our channel to watch more videos like this. Thanks for watching.